Thank you, Mr. Cook and whole team for this great opportunity. And good afternoon, everyone. Today, I'm going to talk about roles of sensors in agricultural sustainability. And I will start by explaining what is sustainable agriculture. Sustainable agriculture involves farming practices that are ecologically sound, means these practices are good for environment. We are using our natural resources such as water and soil in an efficient manner. These are economically viable. So these enables high productivity and profitability for the farmers. And finally, socially supportive, which means these ensures the quality of life for farmers and for community as a whole. For sustainable resource management, we need to understand water, food, energy nexus, which is a multi-centric approach. As we know, there is an increase in population, and with that, there is increase in demand of water, food, and as well as energy. So therefore, we need to study these three components, water, food, and energy together and not separately. And this water, food, energy are interconnected and interdependent. Let me give you a very simple example. If you just think about your lunch, and if you had salad or any animal product, so water was required to produce that food, and then energy was utilized to transfer that food from the farm to the market. So with this very simple example, we can see that these three sectors of water, food, and energy are interconnected, and we need to study them together. So water is required in both sectors to grow food in terms of irrigation and to generate energy in terms of hydropower as well as for biofuel production. And as Dr. Gale mentioned that agriculture is the largest user of fresh water at global scale, and overall 70% of fresh water is used in agriculture. Let's look at some of the water issues. So because of change in climate, we have witnessed there are more frequent floods and droughts. There is a continuous decline in water resource availability, and on top of that, our irrigation practices are not very water efficient. How can we solve these problems? So we need to find out methods that can help us to increase water use efficiency by reducing agriculture runoff and by reducing evaporation. So we need to optimize irrigation scheduling. We need to know how much water we need to apply for any particular crop and at what time. So the overall goal is to grow more crop per drop. And here comes the importance of agricultural sensors. With advancement in technology and with the help of these agricultural sensors, we can use our water resources efficiently. We can use these sensors to continuously monitor soil moisture. We can use machines such as this pressure bomb to monitor water potential, which is an indicator if your plants are well watered or if they are under water stress. And if you are interested in measuring how much volume of water is flowing through plants, you can use these step flow sensors. And you can estimate transpiration and photosynthesis rate using this photosynthesis machine. For the sake of time, I will not be able to go into detail for each of these sensors, but I'm going to talk in detail about soil moisture sensors as well as sap flow sensors. I will share you application of these sensors as well as provide examples where I have used these sensors during my research projects. I will start with soil moisture sensors. So there are several types of soil moisture sensors available in the market, but I have personally worked with these three different soil moisture sensors. So let's look what are some advantages of using these soil moisture sensors. we can measure soil moisture using gravimetric method. But for that, we have to take soil samples very frequently. On the other hand, if we use the soil moisture sensors, it's a non-destructive method. You just need to install these sensors in your field once and you're good to go. And with the help of these sensors, you can monitor your soil moisture continuously. With the help of data loggers, you can record soil moisture at half an hour interval, or at daily scale. And some of these sensors, especially these Hydra probes and 5TM, you can also record soil moisture and electric conductivity along with soil moisture data. And these sensors operate under wide temperature conditions. And the calibration is very simple. Now, if you are just interested at doing spot check, you can use this wireless handheld device, Pogo. And even if you don't want to buy this device, you can simply download this Hydra Mon software on your smartphones. And with help of this software, you will be able to quickly check soil moisture content in your field. Now I'm going to share my research project where I worked with these sensors. So my project was focused on efficient water management in chili pepper production. I conducted this study at New Mexico. As you all know, New Mexico is a hub for chili pepper. Chili pepper is a cash crop in New Mexico, and drought is the biggest issue in that part of the country. So our objective for this project was to find out efficient irrigation methods, and we focused on partial root zone drying, which I'm going to call PRD throughout this presentation. So what this partial root zone drying method is that you are introducing drought in half of your roots and part of your roots, and you're applying water on other parts of root at the same time. We did this study for 2 growing season, 2013 and 14 at New Mexico State University in Las Cruces. So during this project, I have had an opportunity to work with Latino students, and I also had an opportunity to share my data with Latino farmers at regional conference. So in this project, we applied 3 irrigation treatments. So we used drip irrigation method, as Dr. Gale mentioned in his talk. This is like one of the most efficient method, but we tried to make it more efficient by applying this partial root zone drying. My first treatment was control, where we applied the required amount of water for chili pepper, and we applied irrigation on soil surface using these drippers. Our second treatment was PRDV, partial root zone drying vertical, where we applied subsurface irrigation. We placed our drippers at 20 centimeter depth. And the third treatment was PRDC, partial root zone drying compartment, where we divided these pots into 2 compartments, and we were irrigating only one compartment at a time, and then we were switching irrigation after 15 days interval. And I want to point out these shows the placement of my soil moisture sensor in these 3 treatments. So what I found from soil moisture data using this Hydra probe, so I was able to monitor my soil moisture content in these 3 treatments closely. And in this first graph, it shows the soil moisture content that was recorded in control treatment. As you can see, the drippers were placed on soil surface. So therefore, the soil moisture content was greater in top 0 to 30 centimeter depth compared to 30 to 60 centimeter depth. But in the second treatment, which was partial root zone drying vertical, where I applied subsurface irrigation, so the story was different. So the soil moisture content was greater at the deeper depths. And in my third treatment, PRDC, so the soil moisture content changed between two compartments based on when one compartment was irrigated. So with the help of these sensors, I measured soil moisture um, at very short intervals, and I was able to save. At the end of the experiment, I applied 25 to 30% less amount of water in my PRD treatment. Now I applied less amount of water in PRD treatments, but I wanted to see how it has impacted my plants. So for that, I measured photosynthesis in my chili pepper. And for that, I used this portable photosynthesis system, Lycor 6400. You can use this machine or system to measure gas exchange. You can calculate how much carbon dioxide is absorbed by plants and how much water is released by plants through stomatas. You can also measure stomatal conductance. You can record photosynthesis and transpiration rates directly with help of this machine. And on top of that, you can also develop light response curves because you can control light intensity in this head, and you can study how with increase or decrease in light, it will impact photosynthesis and transpiration rate. Now, biggest advantage is that with the help of this machine, you can study your water food energy nexus because you are looking at transpiration rate and photosynthesis, which is the amount of carbon absorbed by plants altogether. I also want to point out that in these photos, I'm using this machine in a natural sagebrush steppe ecosystem, which basically shows that you can use this machine not only in agriculture setup, but also in natural ecosystems. Now, when I looked at my photosynthetic rate data, which I measured using Lycor 6400 XT, I found out that the photosynthetic rates were not significantly different among my three irrigation treatments, control, PRDV, and PRDC. And same thing was recorded during second growing season in 2014, which which is good because even though I was applying less amount of water in this PRD treatments, it did not impact photosynthesis. Similar results I found when I looked at stomatal conductance. So stomatal conductance was not significantly different among three treatments during both years. And this is the reason why, because the stomatal conductance was same, so therefore my treatments were able to maintain same photosynthesis rate. I also calculated irrigation water use efficiency, which is a direct indicator to find out how efficiently water was used among these three irrigation treatments. And how I calculated this irrigation water use efficiency, I looked at the ratio of total pod yield and divided it by total irrigation water applied. As I mentioned before, because I applied 25 to 30% less amount of water in my PRD treatments, but my pod yield was maintained. So because of that, my irrigation water use efficiency increased by 26 to 31% under my PRD treatment. Now, some of you might be wondering if we can use this PRD in field conditions, and the answer is yes. So you can apply this PRD in field conditions, and you can also apply this PRD treatments with furrow irrigation methods and as well as with drip irrigation methods. I have also included this table right here to show that there are several studies which have looked at how you can use this PRD methods to use water efficiently in different types of crops. For example, in perennial crops, starting from grape, apple, pear, orange, you can use PRD in grain crops, including maize, wheat, rice, cotton, as well as in vegetables, tomato, potato, sugar beet, pepper, eggplant, etc. So far, I have showed you how this PRD method can be used to use irrigation water efficiently, but this PRD can also helps to improve the quality of crop. So the hotness of chili can be measured by looking at this capsaicin and dihydrocapsaicin concentrations. And when I compared in my experiment these two concentrations among 3 treatments, as you can see here, I found out that the both capsaicin and dicapsaicin concentrations basically increased in my PRD treatments during both growing seasons, although it was not significantly different. So not only in chili pepper, there are several studies which have shown that PRD improves yield quality and health related properties. As you can see in this table, um, with the help of PRD, quality related properties and health related metabolites have increased in perennial and vegetable crops. And I also want to highlight this one study where they found out that the fiber content also increased in cotton while using this PRD. Now I'm going to switch gear from soil moisture sensors and I'm going to talk about sap flow sensors. For example, if you're not interested looking at the availability of water in the soil, but you're interested at looking how much water is flowing through your plants, in that case, you can use these sap flow sensors. And let me first define what is the meaning of sap flow. So sap flow is basically the movement of water and nutrients. We don't call it just water flow because when water moves in the plant, it also includes nutrients. When you buy these sap flow sensors, it comes with this box, this system, which includes data logger, which can automatically record your sap flow data at an hourly and daily interval. And then there are wires that are attached from the data logger to your different sensors. Let me share some advantages of using these sap flow sensors. So the first advantage is that you can track water movement in real time. So any time of the day, you can basically capture how much volume of water is flowing through your plant stems. And with the help of these sensors, you can record direct transpiration rates. And these sensors are strap-on sensor collars, like you can see here. These are basically collars that you can basically wrap around your plant stems. So these are flexible, which means you can use same sap flow sensors on different crops during different growing seasons. These sensors are also non-intrusive and non-harmful, which means they don't affect the normal functioning of your plants. And you don't have to calibrate these sensors. So now the next question might be, okay, in what kind of crops can we, or in what kind of plants can we use these sap flow sensors? As you can see in this table right here, these sap flow sensors come in wide range of diameter, starting from 2 millimeter to 150 millimeter. So you can buy these micro sensors if you are working on a crop which has a tiny stem, for example, rice and wheat. Or you can buy this stem gauge to work on cotton, sugarcane. And if you are interested using these sensors on trees, then you can buy this trunk gauge. I also want to point out that in this table, you can see how the voltage and power is different, and it varies based on what kind of sensors you are using, basically depending upon the size of your sensors. Now here is an example where I have used these sap flow sensors in my research project. So this is the study which I conducted at Idaho on a natural sagebrush step ecosystem. So I was interested at looking how water flux change among different sagebrush species which are present along an elevation gradient. And with the help of these flow sensors, I was able to record the diurnal curves, so how sap flow changed throughout the day. And I found out that the species which are present at lower elevation under drier conditions were having low sap flux compared to the species which were present at higher elevation and have enough soil moisture available. Now, there are several applications of these sap flow sensors. Although I used these sap flow sensors in a natural ecosystem, but these sap flow sensors have been used in greenhouse studies for water management. You can use these sap flow sensors for irrigation scheduling. You can use these sensors for water balance studies. And here is another examples to show how these sap flow sensors were used to monitor water use over growing season in citrus. So this first graph right here shows how you can track exact amount of water used on hourly scale. And then this second graph right here shows you can also track how the sap flow or the amount of water changes from one season to another season. So in spring, plants were using 5 to 12 liters of water per day. The sap flow increased during summer, and then it decreased again in autumn. And then you can also see the response of these sap flow sensors to rain. When there was a rainfall, the sap flow basically declined.
3-minute warning.
So for example, if you're interested in growing new varieties and you are not sure how much water is required, so you can use these sensors to monitor and to compare how much water is basically used throughout the growing season in different varieties. And here I also want to highlight few crops in which these sap flux sensors have been used. For example, cotton, corn, sorghum, sugarcane, sweet potato. So in conclusion, we can use these cutting edge instrumentations such as soil moisture sensors, photosynthesis machine, and sap flow sensors to precisely measure water and energy flux so that we can improve agricultural productivity, and at the same time we can sustain our natural resources. If you have any questions, please leave in the chat section and I would love to answer your questions. And thank you everyone for your time.